beginning. Perfect. Awesome. Okay. So, okay. So loops and debugging. Loops are quite honestly probably the one concept of, sorry, this is automatically going. I don't know why. No. Yeah. Loops and debugging. Loops is probably the one thing that I would argue makes programming. Loops essentially are ways for program or instructions that you write to execute over and over and over again in a really an infinitely scalable way and with a precision that no human can really ever really duplicate, right? Like one of the things that makes software so powerful is that we can run it 24 hours a day, potentially millions of times every second. And so all of these things that we're doing in which we are writing code, but then also having it execute numerous times, essentially is a loop, right? So today we're going to go over some very basic things about loops. I know that a lot of you may already be very familiar with while loops and for loops, so just kind of bear with me in terms of making sure that everyone's on the same level. But then also, as I talk through it, don't just think about kind of like, oh, I have a general idea of what this is supposed to do. Also, pay attention to the details. Like, try to understand step by step how the computer is actually executing these loops. One of the things I really encourage people to do, especially when they're first starting out, is if you were the computer, right? If you were JavaScript, if I said to you, hey, can you walk me through this process, this loop, this piece of code, whatever it may be, step by step, in a way in which it's not just, oh, and then I think it does this, but rather, what does it do explicitly? Can you actually tell me what the next step is? That's the level of precision that hopefully you'll be at by the end of this cohort, because I would argue that one of the most dangerous things to do when you're first starting off learning JavaScript is just assuming that something works without necessarily knowing why, right? Without being able to kind of explain it to the depths that you would need to kind of really master one of these ideas. We'll also talk a little bit about debugging. And this is going to be more of a conversation than something that we learn. And that's just because debugging is an art in of itself. And I'll talk a lot more about it when we get to that section too. Okay, so the first loop we'll talk about is the while loop. A while loop consists of three main parts. There is the while keyword, a conditional expression, and a block of code. Okay, the while keyword is so in most text editors, if you type in the word while, W-H-I-L-E, all in lowercase, more likely than not, it will show up in a different color than maybe other code that you've typed on this page. And the reason for that is because while is a reserved word in JavaScript. Reserved words are basically words that mean something in the JavaScript language. And so that's why they show up in a different color. It's because they have a predefined definition. The other thing about reserved words, as you'll notice, is that yesterday when we talked about variable naming, we talked about how you should capitalize the first letter of every word except for the first one. If you look at reserved words, you'll notice how it's all lowercase, but there's no definition for it, right? There's no let while equals, because by definition, while is already something that comes built into every package of JavaScript, if you will. Okay, so the first thing we need to do to use a while keyword is on line 6 there. If we look at that while loop, it's just the word while. Afterwards, we go to step 2, which is a conditional expression that evaluates to a boolean. We'll talk a lot more about coercions and booleans tomorrow, I believe, when we talk about coercion and truthiness. But for now, just know that when we talk about conditional expression, we're basically talking about everything in between those open and closed parentheses on line 6. Okay, an expression essentially is just a block of code or a snippet of code that we have to solve. And essentially, what the second aspect is saying is a conditional expression, so something that we solve, that evaluates to a Boolean value. Basically, that means the outcome has to be true, or the outcome either evaluates to a true or a false value. Okay, and we'll talk about why that's really that's really important on the next slide. For this one, just notice, yeah, I believe I am. Let me double check just to be sure. Yeah, let me check. Yep, this is recording. Okay, yeah, sorry. So yeah, so the first thing we need is the while word, with the while reserved word. The second thing we need is everything in those open and closed parentheses. And the reason why we say it has to evaluate to a Boolean value, which means it has to evaluate to a true or a false value, is because that conditional, that parentheses, it tells us when our loop essentially keeps going and also when it stops, right? And that is kind of like the basics of any loop, is just say, when do I start and when do I stop? And that's what the conditional expression is geared to help us do. And then finally, the last part of the while loop is between the end of line 6 and the beginning of line 8. Everything in between those open and closed curly braces. That's essentially is a block of code, and whatever you write in there is just the thing that's going to get done over and over and over again. Okay, and so the block of code is something that's entirely up to you. And so just to kind of boil it down one more time, in terms of these three components of the while loop, the while keyword says, hey, this is a while loop. The conditional tells us, do I keep going with this loop or do I stop this loop? And then the third part, the block of code, is saying, if I keep going with this loop, what do you want me to do? So if we look at a real example here, on line 1 we have a variable called count and we set equal to 3. On line 3 we have our while loop, or line 3 through 6 we have a while loop. On line 3 I see my while keyword there, so I know for a fact I'm dealing with a while loop here. And then also on line 3 I see an expression inside the open and closed parentheses. In this case the expression is while count is greater than or equal to 1. And so that essentially is going to be my go no go decision, right? That's going to either be true or false. Either count is going to be greater than or equal to 1 or it's not, right? There's no other possible conditions. And then lastly, between the end of line 3 to line 6, if I was to execute this loop, what I would do is I will console log out count is and then the value for the variable count. And then on line 5, I decrement count by 1, right? Count minus minus means just subtract 1 from the current value of count. So if I was to run this loop now, the first time I would run it, I go to line 1, I create my variable count equals 3. On line 3, I go to my while keyword, and then within my conditional, I evaluate it. Is count greater than or equal to 1? And so at this point on line 3, the variable count is equal to the number 3. And so 3 is greater than 1, and therefore this is a go, as in I execute the block of code, right? And when I execute the block of code, on line 4, it console logs out count is, and then the value for the variable count, which is 3. And so in the top right-hand corner of my screen, on my output, you see the first line being printed out, count is 3. On line 5, then, I subtract 1 from count, so now count is equal to the value of 2. And now that I've reached the end of my block of code, I then go back to my conditional again to figure out, okay, I ran this loop once. Do I keep running it? And so now, if I go back to line 3, I'm still checking to see if count is greater than or equal to 1, except now my value of count has changed, right? Because on the previous run on line 5, I subtracted 1 from count. So whereas count before was 3, now it's 2. And so now my conditional asks, is 2 greater than or equal to 1? And the answer is yes, it's greater than 1. And so that becomes true, which means, great, let's do the block of code all over again. I console log out count is 2, right? And I see that on the output on the top right hand side. And then on line 5, I decrease count one more time. And I say, great, count was 2. If I decrease 1, now it's 1. My loop isn't over yet because now I need to figure out, do I need to run this a third time? So then I go back to line 3, I go back to my conditional, I say, is count greater than or equal to 1? Well, my value of count now is equal to 1, and so yes, the answer is 1 is greater than or equal to 1. And so I run my loop one more time, and I say, great, let's console log out count is, and then 1. And then on line 5, let me decrease count by 1 again. So now count before was 1, now it's 0. And so then I go back to my conditional one more time, right? Because once again, this loop will just keep running until eventually it hits the stop condition. And so when we reach the stop condition, well, if I go to my conditional, I say, is count greater than or equal to 1? Now the value of count is 0. And so is 0 greater than or equal to 1? It's not. And so at that point, that expression is going to give me back a false. And once I hit that false, that's when I know I should stop running this function. Or sorry, that's when I should stop running this loop. And so at that point, the while loop ends, and I move on to line 7, 8, 9, etc. to the rest of my code. Okay, and so this is a pattern that you'll see a lot, which is that if I was to show you a loop, in an ideal world, I would expect you to be able to kind of walk me through every iteration of what's happening at every single step. It's really important, I think, for you to understand that the condition there on line 3, it runs, right? But it always runs one more time than you think it does because it needs to know, because it will run successfully every time the loop runs, but it will always run one additional time to actually know when to stop. And so that's kind of like the little caveat there that I want to make sure that you're aware of. But are there any questions so far? Yeah. Um, yeah, so what happens, so if you define the variable while inside of the, you mean between lines 3 through 6, like inside your while loop? Yeah, I mean, let count, uh, um, it's not something you should do. And the reason is because expressions are usually meant to be evaluated. You're not creating a new block of, you're usually not executing multiple blocks of code in there. And the other thing is, generally speaking, when you, if you are supposed to go in, if you are going to a while loop, you don't want to be creating a new variable each time, because if you do, your variable is always going to reset to the same value and it will never change over time. You want to go into it having a counter that already exists, right? So I'm trying to think a good analogy for that, right? Um, it's like yeah, yeah. I mean, it's, if you work at a job that requires you to like maybe fill out a timesheet, it's like going into work every day and starting a brand new timesheet. Every time you do that, you lose track of all the previous days that you've worked, essentially, right? So if you go into a loop and you're creating a new variable on the fly and using it as your counter, that means every time your loop runs, you start with a brand new counter that completely has no recollection of any previous times that it's been counted. And so the point of a counter is to say, hey, let me track the progress of this loop over several runs. Okay. Yeah. Are there any other questions? Yep. Um, it's honestly up to you. When you use a comma, it's just another way of appending multiple variables together. Yeah. Yeah, it's more of a style choice than anything else. Any other questions? Cool. So let's go through a few other conditions in for the while loop. If I look at lines 1 through 3 here, I have my while loop, and in my conditional, aka in my parentheses on line 1 there, notice how I just have a false value, right? I have a Boolean false value. And so the reason why on line 2 I put in console log out this line of code will never run is because if I ever try to run this while loop, if I actually walk you through the step by step, step 1 is I go to line 1, I go to my while loop. Step 2 is I check my conditional. Is it true or false? It's false. That means I stop. That means my while loop is over. And I move on to line 4, 5, 6, etc. Right? And so this highlights a pretty important principle, which is that a while loop is always going to run at least once. But if that command is to stop, then you'll never execute that block of code, right, on line 2. And so just because you see a while loop and just because you see a block of code, don't assume that that's going to run at least once, because as in this example here, it may not. The opposite problem could also occur very well, and I think this is something that Rick just mentioned, which is that I could also have something like this, where I have my while loop. In my conditional, all I have is true, right? And in my block of code, I have a console log out. This line will run forever. If I try to run this while loop, step 1, I go to line 1 and the while keyword. Step 2, I go to my conditional, I evaluate it. It's true, so therefore I go to the block of code. I console log out. This line will run forever. I then go back to my conditional to check if I should run again, and it's still true. So then I console log out line 2 again. This line will run forever, and that cycle will repeat, infinitely. And the reason why is because notice how in my conditional on line 1 there, inside the parentheses, true is always going to be true. That will never change. And so therefore, this loop will never ever receive a stop instruction. And so this loop will indeed run forever. And so on the last slide, we saw a case in which it checks it once and then stops, or rather, it never really gets started running. Here we see a scenario in which it will actually run and never stop. And this is actually quite common. This is what we call an infinite loop. And this is something you should definitely be very careful to avoid, right? Anytime you write a loop, it's always very, very good as a step 0, really, just to make sure that you're very clear on when the loop starts and also when the loop stops. Nowadays, if you run this, the computer usually will, like in the old days, the computer actually probably just break in some variation. Nowadays, most computers are pretty intelligent. They'll say, hey, I think you meant to not run this infinitely. But yeah, this is definitely a mistake that you want to avoid. And so if we go back to the first example that we did together as a group, right? We see it on lines 1 through 6. The only difference now is after line 5, on my previous slide, on the first example I had a count minus minus, if you remember that, right? Which means I decrease count by 1. Here, if I take away count minus minus, well, count is defined as 3 on line 1. On line 4, I check count is greater than or equal to 1. And so on line 5, I console log out count. So at no point on this page am I ever modifying the value of count. And so count will always be 3. On line 4, my conditional expression, 3 is always going to be greater than or equal to 1. And so therefore, I hit up another example where this is going to be an infinite loop, right? Because 3 is always going to be greater than or equal to 1, which means on line 4, my conditional is always going to be true. And therefore, this loop is always going to keep getting the go signal, and it will never get the stop signal. And so it's super critical. So it's super critical to us that whenever you write a loop, that you're always moving towards a world or towards a condition, we say, in which eventually the conditional expression is going to be false, i.e. that the loop is going to stop at some point. Any questions on anything I just said around while loops? Yep, I'm still here. Yep. On this page right here. What plus are you referring to? Sorry, which line number are you looking at right now? Okay, so line 5 says console log out count is comma count. Okay, so your question is, okay, sorry. So, okay, yep. So right here, or I've highlighted it. Okay, what about it? Two equal signs is usually used for comparison. So that's different than the variable itself. I don't think there's a. So if you're talking about plus equal, that's also an expression where you're adding 1 to something. But like there are ways to change a variable, but like nothing will ever like this, like the variable is what it is, right? Like if we like at this point all we're saying is, hey, like what is a variable here? I just want to print it out for us. we're not looking to change it. And in fact, we're not changing the variable anywhere else on this page. On the first example we did, we had count minus minus on its own line. And in that line, we're saying, hey, let's decrease the value of count by 1. And so there we're explicitly making the decision to change that variable. Here we're not making a similar decision. Right, because count is 3. 3 is on line 4 here. We check to see if 3 is bigger than 1, which it always will be. And so therefore this is an infinite loop. Yep. Okay, cool. All right, so now moving on to the next section, which is the for loops. This is the one that I think most people are more familiar with, but in my experience, this is also the one that people are like the least familiar with. I think there's a perception of, oh, it does this magical thing, and then we just kind of take it for granted. And here we'll just kind of walk through the nitty-gritty of how it's actually working. So a for loop, much like the while keyword, also has 3 parts, although it's arguable if step 2 is 3 parts or 1 part. So we still have our reserved keyword. In the previous while loop, the reserved keyword was while. Here, the reserved keyword is for, right? And so we start off everything with a for. It's a word that comes predefined in JavaScript. It means you're going to write a for loop, and so that's, don't try to change any part of that. We still have our expression, aka we still have our open and close parentheses, but now within it we actually have 3 segments, and we'll talk about each of those 3 segments. And then last but not least, we still have our block of code, right? So everything that exists in between the opening and closing curly braces. And so at a high level, this looks very, very similar to the while loop, right? The only difference is now that we've replaced the while keyword for the for keyword. But the most important difference here is actually what goes on in between those open and closed parentheses. So the for loop within those open and closed parentheses, there's actually 3 components to it. There's something called the initialization, there's a check, and then there's what we call the final expression or the incrementer. So if I look at line 9 here, right, I have my for keyword, I have my open and closed parentheses, and all we're saying is that in between those open and closed parentheses, there are 3 parts to it. And each part is separated from the other parts by a semicolon, right? So on line 9, if I look at that code there, the first part is let I equal 1, semicolon. That's the first part. The second part then is I is less than or equal to 3, semicolon. That's the second part. And then the third part is I++. That's the third part. And so if we break down what each of those 3 parts mean, the first part is what we call the initialization or the initializer. That's basically only run 1 time ever over the course of the loop. And to go back to Rick's question earlier about can I create a new variable just for this loop, the for loop is actually designed to do that. And so here's where we're creating it, right? On line 9 there, when I run this for loop, let I equals 1, that is only run once ever over the life of this loop. And we're essentially saying is, hey, I is going to be the counter. I is going to be the variable that we use to track the progress of this loop. The next part then, I is less than or equal to 3, that's the conditional check, right? And actually that's the same check that we saw in the while loop, as in this is going to be an expression that's either going to evaluate to true or false. If it's true, it means we keep going with our loop. If it's false, it means we stop and we end the for loop, okay? And so that's the middle part. The last part then becomes what we call the final expression. I call it the incrementer. And what that does is saying, hey, after each time I run this loop, how do I change the counter? How do I change the variable so that theoretically I'm getting closer to a stopping point? Okay. And so if I was to actually kind of walk you through this for loop in a step-by-step way, step 1 is when I run this for loop, the first step is I execute let I equals 1. So now I've created a variable called I and set the initial value to 1. Okay, and that's this part here. In the next part, I do my check. I say is I less than or equal to 3, i.e. is 1 less than or equal to 3. And in this case, I get back true, it is. And so that takes me to the next part of the code. The next part of the code actually, and this is a bit tricky, it's actually the code block, right? Because essentially what this piece, what I is less than or equal to 3 is saying, do I have the green light to run my body of code? And the answer is yes, I do. So once I have a green light, well, I'm going to run my body of code. I'm going to console log out I is, and then the value of I. In this case, initially I is 1. So I console log out I is 1. And then after I run my body of code, only then do I run this third part, or the incrementer part, right? And say is, how does I change? Well, in this case, I say, let's just add 1 to I. So now I becomes 2. And now I'm finished more or less with the first iteration of my loop. But I haven't gotten a signal to stop yet, so I keep going. So where I go next? Remember, this part only is ever run once, so the next part of my code is actually run here again. Now I run my check one more time, and I say, if I keep going, to keep going, I need to figure out if I is less than or equal to 3. Well, the value of I is now 2, right? Because it was 1, I've added 1 to it, so now it's 2. Is 2 less than or equal to 3? The answer is yes, it is. So I say, great, it is. So I have the green light to run my body of code. And running my body of code requires me to run this part again. And now I console log out I is 2. After the body of code runs, I then run my third part of the increments. And I say, great, let's increment I by 1 more, which is going to make 2 equal to 3. And then I go to the next iteration, which is still here. And I say, great, is 3 less than or equal to 3? And the answer is yes, it is. And then I console log out I is, and then the value of I, which is 3. But I'm not done yet because I still haven't gotten the stop signal yet, right? I then increment 3 by 1, so now 3 is 4. And then I go back here one more time and I say, great, is 4 less than or equal to 3? And the answer is no, it's not. And so only at that point do I say, okay, great, I am now finished with my for loop because I've hit a scenario in which my check gives me back a false. Notice how I've ran this variable once and only once at the very beginning, and that's very critical, right? Because if I run this every single time I run the loop, if I run this for every iteration of the loop, then I reset I to 1 every time, and my loop will never stop, right? But by only running it once ever and then doing the check, and then doing the check here, and then incrementing it here, I will reach a world in which eventually this becomes false, and I know when to stop my for loop. And so this is the guts of how a for loop is actually running internally, right? Is that it always initializes a counter, and then it checks. If it's true, it does a body of code, and then it changes the counter. Checks. If it's true, does a body of code, changes the counter. Checks. If it's false, then the for loop actually stops right there, and we move on to lines 12, 13, and 14. Any questions? Yep. So the most common reason for people using while loops is when you don't necessarily know where you're going to stop or when you're going to stop. And so for what a common example that people always use for while loops is saying, hey, I have a loop that's going to roll a die, right? And it's going to stop once I get a 6. I know it will probably stop at some point. I just don't know when that is, right? And so in that case, a while loop is more appropriate. A for loop is usually used when you know for sure when you're starting and when you're stopping. To say, so if you're saying, I want to run this function 15 times, a for loop is very appropriate because now I can set I equal 1, I can set my check equal to 15, and if I increment I by 1 every time, I've now kind of very explicitly laid out my start and stop conditions. Yep. Any other questions? Okay. But I guess just to add one more detail to Rick, almost all for loops and while loops can be rewritten as variations of each other if you really wanted to. And so usually speaking, people will prefer for loops over while loops just because with while loops, you actually kind of do run this risk of having the loop never end. Whereas with a for loop, it's very clear when the loop starts and stops. And so it just seems in some ways almost like a safer tool to use in that regard. Okay, cool. So just to run through a few other examples of for loops, right? Notice how if I have a loop, right? If I have my initial variable, I have my check, and then I have my incrementer. At no point do I ever say, oh, I'm going up by 1, or I'm going down by 1, or I'm going, in a direction with a different number, right? All it does is or rather the point here is to show you that for loops don't really have a sense of direction. There's no sense of I'm only ever incrementing or I'm only ever decrementing. I could change it, right? So before it was start at I equals 1 and go up until 3. Here we're saying start at I equals 5 and go down until 1. And that's totally valid because at every step we're following the traditional for loop workflow, right? Which is create a counter, check it, change it, right? And that change could either be bigger or smaller. In fact, it doesn't even have to be by 1, right? Here I start at 100. I'm trying to go up to 300 now, but on line 2 there, or sorry, if I look at that third condition there, or the incrementer, rather than going up by 1, I'm going up by 100 every time, right? And these are all fair game because essentially, once again, we're still following this framework, if you will, of let I equals a counter, we check the counter, we change the counter, and we run that over and over and over again. And so there's no sense that in a for loop you have to go by 1 every single time. In fact, you can choose any modification to the number by any amount that you want. Okay, one of the more common examples that you'll see for us using a for loop is actually to go through things that we call iterable, or rather things that are lists, right? And so one of the more common data types in which we kind of use this practice for is a string. We might see a string as, oh, it's a word, right? But really to JavaScript, what a string is it's a collection of sequential letters, right? Every letter in that string has a position, which is called the index, and we access that position by using the square brackets that we see on line 5. We'll talk more about this when we get to arrays, but for now, just kind of for the purposes of this example, just know that we have a string, which is a list of letters, if you will, and we access each letter by the position, and we pass in or rather we insert the position by putting in between these square brackets after the string. So here, if I wanted to print out every single letter in this string, I can use something like a for loop to do that, right? When I run this for loop, the first step is I say let I equal 0. So I'm just making an I'm making a completely brand new variable called I set equal to 0. The check is while I is less than the letters out length, so while I is less than however long this is 7 letters, so the length of this is going to be 7, and then I++. And so when I run this for loop, I equals 0 is the first thing I do. Then I check, is 0 less than 7? And the answer is yes, it is. So then I go to line 5, I run my body of code. Current letter is equal to a letter and then index 0. So the character at the 0th position, right? So the first character of this string variable. In that case, it's the letter A. And I console log out current letter, which is A. I've now finished my block of code. I move on to the third part. Oh, sorry. Oh, that's annoying. Okay, so all right, highlighting is not okay. I can't highlight. Anywho, so I finished this body of code here. I then move on to the third part, which is I increment my counter, and now I is equal to 1. And I do my check again. Is 1 less than 7? Yes, it is. So now let current letter equal letters at position 1, which is the second letter, which is B. And so I print out B. I increment I. I do this basically over and over and over again until I get to I equals 6, right? If I say is 6 less than 7, the answer is yes, it is. So then I say let current letter equal letters index position 6, right? So basically the letter G. I print out G. I then increment I one more time now. So now 6 becomes 7. Is 7 less than 7? The answer is no, it's not. And so then I stop. But by going through this loop, what I've also done is I've also been able to print out every single letter in this string. And so this is just like a very common example of how we use a for loop to navigate a list of things. You'll be definitely doing this today for some of the workshop problems. So if you need a quick reference, it's great to come back to this slide in particular just to take a look at kind of how we did it here. But as a caveat, I'll say this, or rather you'll hear probably other instructors say this many times over the next few weeks. Never copy code you don't understand. Don't just blindly copy and paste something, because if it breaks, then you have no idea why it's broken. So always make sure you understand what a code is doing before you decide to use it or copy it. Any questions? Okay then, cool. So just two more concepts on loops and then we'll wrap up for today. The first concept is this keyword called continue. If you notice what I've done with with these loops is that we run through the code and we just kind of keep going through it over and over and over again and eventually we stop, right? What the continue keyword does is says, hey, I don't want to stop this loop, but I want to skip the rest of this particular iteration. And so, but I still want you to keep going on to future iterations. And so what does that look like? Well, if I look at lines 2 through 8 here, right? I have a for loop. I start my counter at I equals 1. My check is to make sure I is less than or equal to 5. And then after every code block run, I increment I by 1. So far, pretty standard, right? I start at 1, I'm trying to go up to 5, and I add 1 to I every single time it runs. Inside of this code block, if you notice on lines 3 through 5, I have a check here. On line 3, I check to see if I is equal to 3 or not. If it is, then on line 4, I execute the continue keyword. Okay, no else clause. On line 7, I then go and execute and print out I is blank. And so if I run this code, right, on the first run, I is 1. Is 1 less than 5? Yes, it is. I go to line 3. Is I equal to 1? Or sorry, is 1 equal to 3? And the answer is no, it's not. So then I skip my if clause. I go to line 7 and I console log out I is 1. And I see that printed out on the top right hand corner of my screen again. I then add 1 to I, so now I is 2, and I do the same check one more time. Is 2 less than or equal to 5? And the answer is yes, it is. And I go into my code block. Is 2 on line 3, is 2 equal to 3 or not? It's not. So I skip lines 4 through 5. I go to line 7 and I print out I is 2. I then add 1 to I, so now I is 3. In my for loop in my check, I ask is 3 less than or equal to 5? And the answer is yes, it's less than 5. I go to line 3 and I say is 3 equal to 3? And the answer is yes, so I go to line 4. And here on line 4, I hit my continue keyword, and all continue is saying is, hey, skip the rest of this code block, as in skip lines 5, 6, and 7, and then move on to the incrementer, move on to I++, right? Basically skip all of this and move directly onto this, right? I want this loop to keep going, but I'm done with the rest of this particular iteration, i.e. I'm done with the rest of this I equals 3 iteration. And so what the continue keyword is saying is just, hey, move on to the next iteration of this loop, but skip the rest of this iteration. And so then when I do that, 3 becomes 4. If I do I++, is 4 less than 5? Yes, it is. I go into my code block, is 4 equal to 3? No, it's not. So I go to line 7 and I print out I is 4. And if I go through my printouts, notice how I print out I is 1, I is 2. I skipped, or rather I is 3 got skipped, right? Because I is 3 would have printed out on line 7, except on line 4, we told the for loop to skip the rest of that iteration. So we skipped lines 5, 6, and 7. So we never printed out I is 3. But then obviously we go back to printing out for I is 4 and I is 5 because we don't skip the rest of those runs because once again, the continued keyword on line 4 is only triggered when I is equal to 3. And so once again, not to belabor the point, but all continue is saying is, and once again, continue is also a reserved word in JavaScript, all continue is saying is, hey, skip the rest of this iteration, but keep going on to the next one. And this works for a while loop, for a for loop as well as a while loop, right? Feel free to look through this example in more depth if you have time, but essentially all it's saying is, if you look at the while loop on line 4 there, all the expression is saying is, hey, while count is greater than 1. And then on line 5, in order to trigger the continue keyword, all we're saying is if the remainder, when we divide count by 2, is equal to 0, i.e. if the number is even or not. If the number is even, then we go to continue. If it's not even, then we skip that if block and we go to lines 10 through 11, right? So we print out what count is. And so if we look at the number that gets printed out on the top right hand corner of our screen, notice how only the odd numbers gets printed out, right? And the reason why the even numbers are not get printed out is because on line 5, if we check and find out that the number is even, then we continue, which means we skip the console logs on line 10. So the continue keyword, the reason why I bring it up is we want to contrast it to something else called the break keyword. What the break keyword does is break keyword operates very similarly to continue. It also skips the rest of this iteration, but it also skips all of the future iterations as well. And so whenever you see the break keyword, it basically just means it's like an emergency exit button. All it says is, hey, end this loop right here. Okay, and so if I look at the example here, if I look at my while loop, you know, sirens are going off because I see in my expression on line 4 there that it's true, as always true, as in this while loop will never finish. But if I go into the body of my code, I see that my grade is a string. We're adding pluses to it. And on line 7, I says if my grade.length, so if my string.length, if the length of that string is equal to 3, so if it's a++, then I hit line 8, which is break. And as soon as I see break, I know that all that means is that my loop is over at that point. And so if I run this while loop, my grade is equal to a. On line 4, I do my while loop check. Is it true? Yes. So I keep going to my code block. On line 5, I add a plus sign to a, and on line 7, I check is my grade.length equal to 3 or not. After the first add, it's just a plus, which is only a length of 2, so it doesn't equal to 3. So I skip lines 8 through 9, and I go back to line 4 to do my check again. Well, true is always going to be true, so I know I need to keep running my code. I then add another plus to my a, and so now my string is a++. On line 7, I check is a++ is the length that equal to 3. It is. So then I hit break, and I've ended my while loop, despite it not having a false condition in my expression there. The break basically means end my while loop then and there, and I console log out a++. And just like how it works for while loops, it also works for for loops too. Essentially, as soon as I see the word break, it means end the rest of this iteration as well as all future iterations, which basically means end this loop here and now. The continue keyword means, hey, let's end this iteration, but let's keep going to the next iteration, right? Do the rest of the loops too. So yeah, so that's continue and break. So that pretty much covers everything we're going to cover today for loops. Are there any questions here? Usually you do, right? Because there's usually a condition under which you want to skip either this run or, yeah. Sure. So in this example here on line 5, right, we say if I is equal to 7, then you stop the loop. But what if we don't know what 7 is, right? What if 7 is actually a variable that changes each time we run? And so let's say, like if I'm making a dinner reservation, right? I say, like, hey, I have a table for 4, right? We can take the next 4 guests off this list. But if a table for 10 opens up, I can take the next 10 guests off that list. And so every time I run this for loop, let's say this for loop is trying to take names off of a wait list, right? Depending on what that 7 could be, is that's 7 with a variable, and every time I run this for loop, that variable changes. Then this for loop is actually very useful, or the break is very useful, right? Because it tells us, hey, only stop if if I is equal to this super custom number that we're using this one time. Now, there are other ways to write the code I just described without using the break keyword. But the point here is just to show you that, yes, if I know for a fact that I is always going to be 7, then yeah, I should probably just write my for loop so that it starts at 10 and ends at 7. But if I don't know it's always going to be 7, if that number is dynamically changing over every run, then it becomes a lot more important for us to have that if check, and then obviously to have the break run when we reach that condition. Yep. Any other questions? Right here? Because there's only one console log on this page, and it runs after the while loop is over. So I only run whatever my grade becomes after this loop finishes. Yep. Any other questions? Great. So the last thing we'll talk about today is debugging. This will take 5 minutes, hopefully. Um, there's not a lot to quote unquote learn here in terms of memorization. Debugging is all practice. And I think when most people start off writing code, they think, oh, great, I'll spend most of my time writing code. But if you ask most experienced developers, like, out of 100% of your time, if you had to write a new piece of code, how would you divvy up, that time? I would say most developers say, a third to 40% of the time is reading the existing code to understand how your new code is going to fit in to make sure you don't break anything that was there before. Maybe 20% of the time is spent actually writing the new code, and then the other 30 and 40% is trying to debug it, fix it, make sure it doesn't break anything else going forward. The point is to say that debugging is going to take up a lot of your time. It's an art form, and you'll spend way more time doing it more often than writing new code itself, right? So just because you're spending a lot of time debugging and fixing things, it's not a bad sign. It's part of the natural process. There are a few tips that we want to kind of share with you regarding how to maybe potentially debug more efficiently. And one of the reasons why we have you use a CodePen software is because it has tests on it. And tests really are a good way for us to kind of verify, hey, is your code doing what we expect it to do? It's a little bit overwhelming at first, but hopefully once you do it a few times, you get the hang of it. Every time when you run a code in CodePen, you'll have a place where you type in your code, and if you click Run at the top right hand corner of your screen, or at least middle top of your screen, it will run it against these tests that we've already prepared, right? And so some of the more common, and so if your test passes, then you'll see this green dot here. Well, you can't see where I can't highlight it, but you'll see this green dot here. That means your test passed. Every red X means, hey, your test didn't pass, or rather you didn't pass this test. Your code, when we ran this test, we expected your code to do something, and it didn't do that thing. And so here I'll tell you, here there are 4 tests here. We notice 1 green dot and 3 X's. That means you have 1 pass test and 3 failed tests. But more importantly, down here, we'll actually tell you for the test that failed, what happened, right? So the first error that you'll see is something called a reference error. This basically means you try to use a variable that doesn't exist. And it just to kind of give you a heads up, usually when you're first starting off, you'll see a lot of reference errors. And the reason for this, there are 2 main reasons for this. One reason is that you essentially were trying to use a variable that you didn't create or you couldn't access. Or 2 is that you're trying to use a variable that you misspelled. Right, so if you create a variable called David, let David equals number 6, and then you try to use the variable David somewhere else, but you spell it D-A-V-D, you forget the I, well, JavaScript is going to throw a reference error because it's going to say, hey, the variable DAVD doesn't exist, right? And usually that's just due to human error. And so whenever you see a reference error called sum is not defined, 1, always make sure that you've defined the variable correctly. You've spelled the variable correctly. And then 2 is make sure that, and we'll talk a lot more about this when we talk about scope, make sure that wherever you're using that variable, you actually have access to it. Because if you don't have access to it, then essentially it means that that variable doesn't exist as far as the computer is concerned. That will probably be less of a problem for today's workshop, but you'll see how it becomes a much bigger problem when we talk about scope. Okay. If you keep looking at this error screen here, you'll see it tells you kind of not only what the error was. In this case, the error is a reference error and saying you try to use a variable called sum and you never defined it. But it'll also tell you how it got there, right? And so this here is what we call the stack trace. This tells you how do we get to this point? How do we get to the error? Which lines of code were run? And so usually these first 2 lines of code are not really important. But if you look at the last line I ran before we hit the error, you'll notice that it was for this file called onlygods.js, and you'll see 2 numbers after it. The first number is the row number, and the second letter is a character number, right? This means that the error occurred when we try to run code on line 11 at character 7. Usually the line number by itself is sufficient to say, hey, I hit the error when I tried to look at line 11, and that's a good sign for you to start looking at line 11 to figure out what happened. Just because an error occurred at line 11 doesn't always mean the error is at line 11, right? So, example I always say is, let's say I left my car keys at home. Well, I'm not going to discover that error until I get to the parking lot and try to open my car door, right? But it doesn't mean I left my car keys in a parking lot, right? Even though I was in the parking lot when I discovered my mistake, the mistake could have been caused beforehand elsewhere. So whenever you see this trace, and we look at the line, the last line that got run before the error was detected, think of it as at worst a starting point for us to start exploring what happened, right? It doesn't mean the error is always there. Failing tests, there's two kinds of tests that fail. The first kind is to say that, hey, your code didn't run. As in, there was a spelling error, there was a reference error somewhere, like I couldn't run your code. The second type of error is to say, hey, the code ran fine, but I didn't get the answer that I expected, right? And then so here, you'll see this error, which is not really an error, this is like a test outcome, which says, hey, I expected blank to equal blank. And this means that, hey, I expected your output, which is the first number, to equal whatever the right answer is, which is usually the second number. So in this case, the function ran fine, but when we add up the sum of all the odd numbers between whatever number we gave it and 0, it expected to get back 25, instead it got back 55. So the code ran fine, it just gave us an incorrect answer. And so the tests usually are designed so that you can kind of take a look at it and kind of a good sense of, oh, like what they're looking for and kind of what the failure or what the error actually is. Lastly, the last thing that you'll see in terms of errors is sometimes you'll also see expected undefined to equal something else. Undefined is basically what we get when you don't return any value out of a function. And so if you do see hey, I'm getting undefined, try to make sure that your function whatever you're running, it's actually returning something. Returning something is very different from console logging it. Console logging is only meant for human consumption. It shows the person what's going on. It doesn't actually return. It actually doesn't give back a value to anywhere else as far as JavaScript is concerned, right? So make sure that if your function is supposed to be outputting something, make sure to always be returning that value. And if you don't return anything out of a function, then by default JavaScript will return undefined. And so that's why sometimes we see this error is I expected to get back something and I got back undefined. That just means you didn't actually tell your function what to return. As you go through the examples on CodePen, if you scroll to the bottom, you should never ever edit a test, right? It's like trying to pass a math test by changing the questions. It defeats the purpose of it. But feel free to look at the test to try to figure out kind of what it's doing and kind of how it's running it. On line 12 here, if you look at the example here, we'll always put in a string that describes the test. And that test will usually always, the name of that test will always jive with whatever is being printed on the red bar here too. So it's really easy for you to say, oh, I failed this test here. Let me look at the actual test to see what it's doing, right? The names we try to make the names as descriptive as possible. But obviously, a lot of times it does take you some time to kind of read through it and walk through the test to figure out what's going on. The debugger and then some VS Code stuff I'm not going to go through just because at this point I feel like it actually makes your life harder. It's almost like giving you kind of too sharp of a knife to use this early on. But at some point, if you get more comfortable with writing code and debugging and you want to know some more advanced tools, we do have some some slides here around dev tools, around debuggers, around VS Code that could make life a little bit easier for you. But like I said, generally speaking, my experience has been that if we cover it now, it actually does more harm than good. And so for debugging, just kind of understand that when you run a test, if it fails, try to figure out why it fails, and give you some quick guidance on kind of how to maybe more quickly identify what happened, right? What the actual mistake was. So any questions?